It's a great honor to be here. Hope the people in the Zoom is able to listen to me. The topic of the presentation is very much related to the theme of the conference. It is deep learning applications for automatic medical image analysis to support telemedicine in 4IR. Yeah, so actually I like to thank everyone who directly supported me for to be the global women in engineering chair of the whole world. It's a great honor to serve the whole world staying in Bangladesh. Uh, yeah, and you may know about IEEE Women in Engineering magazine. It is a world-class award-winning magazine. And in their June issue, they have published my interview. I'll try to forward it to all related to me so that you can share it to your network. It's not a matter of knowing my accomplishments. It's a matter of let you know that how I can help you and how I can reach out to you. Uh, I'll be very fast. This is my website actually. To know about me, to visit my website www.celiashanas.com, and also visit my Google Scholar citations that despite many limitations of funding and competition facility, number of PhD students, how my students are working very, very hard to really publish impactful journals and conferences, impactful journals. And this is I think it's a bit inspirational staying in Bangladesh. Uh, Let me, oh, it's going up, going very fast. Okay, let me fix it. Yeah, actually, I will focus on a topic that is really very difficult to do automatically. That is the tuberculosis detection from the chest radiographs. Radiologists, what they do, they see the radiographs hours after hours and provide solution visually, but we want to automate that process. To automate that process, uh, we are proposing a method where in the first lower wing, what we do, we take ensemble of deep learning networks. In the upper arm, we take ensemble of the machine learning approaches, and then we take both the ensemble to get a better decision. This is exploiting the potential of deep learning approaches and exploiting the potential of machine learning approaches, and ensembling of them and cascaded operation of them is always giving a better result. Is going back. These are the handcrafted feature we usually apply as histogram of oriented gradients, binary pattern phase concurrency, improved Weber binary code, curvature descriptor histogram, shape descriptor histogram, local arc pattern, local transitional pattern, median binary pattern. However, we did some sort of augmentation like element-wise power augmentation, Gaussian filtering, and sharing. So this is really important to know the quality of the features extracted using handcrafted one by Bhattacharya distance and geometric separability index. If you look at them, that all features, the BC and GSI are very low. That means the feature is so compact and high quality. And this we have shown with two publicly available database, which is it's a biomedical data, MC and Shenzhen database. We evaluated them under evaluation matrices, accuracy, area under the curve, sensitivity, specificity, and we have seen the values obtained for the individuals one are lower when we do the ensemble of the all handcrafted feature. If you look at the value accuracy, the ensemble one is 92.8%, which is higher. And then before moving to the deep learning approaches, we have evaluated the performance in two databases, And we can find that which architecture and which level of the architectures like Inception V3, DenseNet, and ResNet 50 are giving the best result, and the best results are shown by the shown by the bold ones. Once we know that who is giving the best results, then we do the ensemble. And while doing the ensemble, we have reached to two solutions at that, whether we will do pretain or not pretaining, whether we will do augmentation or without augmentation. And we can see that with pretaining and with augmentation, the ensemble giving the best results. Once the features are obtained, they are given to the sent back to the classifiers. There are different types of classifiers like regression analysis, support vector machine, KNN, random classifier, and among all these classifiers, we can see that the logistic regression providing the best results, okay? And this is time for our method to compare with all the state-of-the-art methods, you know. It is really important that where you stand and the ensemble of hand engineers and deep learning network are providing the best result compared to all the existing methods in the literature. That's why this is published in IEEE Access. This is a very uh, renowned journal papers. Let's see the picture. Do you want to see it visually? Yes, if you see it visually, then you can see that upper row is normal and lower row is tuberculosis, right? But we don't want to do it from visual observation. That's why such automation has been proposed. And now comes the architecture of telemedicine. That means our Prime Minister has arranged community clinic and smartphone in the community clinic. We may not have a smartphone for everyone, but we have community clinic on smartphone. From there, you can send the tuberculosis data to the server with security, and server can learn the machine learning and deep learning approach that I have proposed. And then that data can be sent to the PC or to the smartphone in another community clinic where doctor is sitting, right? Doctor, we cannot overnight send our doctors to the hill tracks, right? Even if doctors living in other city, and even the women or a tuberculosis patient living in, I think, Cox's Bazar, it's not a very difficult if we can use this structure of telemedicine. And in Bangladesh, we have all the capacity. We have your community clinic, we have our community clinic, we have our smartphones, we have our, also we are now habituated with the cloud computing, and then we have a lot of people who are using SMS and phone. That means sitting one place, you can send your data and cloud, it will be calculated. The result will be sent to doctor for monitoring, and doctor can communicate the patient to do the diagnosis. This is the structure of whole telemedicine. Hope it is clear to us. Now, the work that I have proposed, it has a potential for telemedicine because, you know, during the COVID-19 or after the COVID-19, there are some efforts such as social distancing, quarantine, and other things. Medical professionals were actually having great challenges in delivering healthcare to the tuberculosis patients. So in this context, telemedicine actually can help to deal with the ongoing healthcare needs from TB patients while reducing the in-person clinic visits, because it's not always possible to have the in-person clinic visits. Besides, telemedicine can deliver the special health care to such patients to distance regions, no matter he or she should be always in Dhaka near Square Hospital, and provide, it can give patients care to places where there are preserves and other services are not available, and medical supplies are not preserved. So, but if we can send the information to such places, the high quality medical supplies can be preserved who are actually not capable of going face to face. In this way, we can reduce the human exposure. So proposed computer aided deep learning method, which is a 4IR technology, and that is automatic TB detection, is easily reachable to any corner or any people of any corner, which is time saving, more accurate, thus able to create a huge impact on the community and humanity. That is our work. Actually, we want to do such work that will help billions of people. So okay, that way we can connect, we can support our SDG. These are some of my awards that I have owned from Asia Pacific region. Women in Engineering Best Award from Asia Pacific, Women in Engineering Best Award from the whole world, Leadership Award from the whole world, Humanitarian Activities Outstanding Award from the whole world, and MG Achievement Award for the whole world. These are other achievements. Group award, I'm proud of all my ambassadors. These are our chapter, Engineering Medicine, became the regional outstanding chapter award in the whole world, and our chapter Signal Processing received the chapter certification very well. So I think we can change the world as we are engineers. It's possible, but only thing is that we have to always propose that what is our method, why we are doing it. First question, whenever I discuss any, say I was discussing tuberculosis, then my student asked why there are a lot of radiographical and a lot of images, why tuberculosis? I then gave them a number that how many billions of people are suffering from tuberculosis in Bangladesh and how it is handled. It is handled always face to face. So that's why we felt motivation to propose a deep learning based architecture and automatic architectures. And I have already shown you the potential of giving that service through the cloud service. And I can show you that it is easily accessible to the people of any kind. You know, you do not need to be rich, because our community clinics are accessed by our normal people, right? Our community clinic has at least one smartphone, but in village you may not have smartphone owned by all. That means that you do not need to do the capacity building to accommodate our research. The already resources offered by the government and Honorable Prime Minister is capable of handling such computer aided diagnosis and give service through telemedicine. And after lockdown, it has become so prominent, it has become so much needed that we reach telemedicine service to all. So thank you for your patience. If you have any question about this healthcare and telemedicine, I will be able to take at least one question.
Thank you very much. So have you any question from the audience? So I have one question, madam. What about the cost?
Oh, the cost, you need a fast computing GPU only.
Nothing
else. You know, because our community clinics are connected by the servers. That means my whatever research I do, I try to do a research that does not do a lot of infrastructure, because that takes a lot of funding. I always look into what is existent in our country and try to do global level research so that we can publish in impactful journals and conferences. That's why we heavily use deep learning, so that we remain in the emerging area. At the same time, we keep in mind that it has to be implemented. There should be a vision. It should not be just for publishing paper for my promotion. So that's why I always address the issue that what is the infrastructure available in our country, whether the existing infrastructure is capable of handling it, whether our people can benefit of it without investing anything from their part, just a regular visit. Okay, and we cannot force our people, because it is depend on people's ethics. What a person will do, it depends on people's ethics. A doctor is posted to hill tracks, right? And if he or she does not go there, we cannot really force. We cannot, it depends on his or her ethics, but we cannot stop. The problems, diagnosis, and medicine cannot be stopped. So that's why this is a solution, that how you can close the circuit, how you can tell people, convince the government that yes, it is possible to do a research using the existing services, and it is important to utilize the telemedicine, because after COVID, I really don't prefer any face-to-face meeting, because it can come back anytime. In China, it is coming back many times, and now even I cannot go to China for any visit because different state has different quarantine. So in that case, if possible, avoiding human exposure, if we can treat our people, then that's the best solution, rather than flocking everyone in the Dhaka. That's the motivation.
So thank you, madam, for a good presentation.